Welcome back to our stream where we are programming an NES game live on stream on Twitch. This is the 18th stream that I've done. I'm going to just jump right into it because last time it was a bit of a mess. I changed the asset tool to change it over from generating code in assembly to generating data instead. And the idea was I wanted the game to read the data instead of just having the code for populating sprites get assembled into the code from the asset tool. So yeah, so that was kind of crazy. It didn't work out the way I wanted it to. Ended up spending about 3 hours on Monday trying to figure out what was broken, and finally got it partially working, only to find out that the performance was terrible. So by the end of the stream, I had realized that I could probably change the code a little bit, because right now what it's doing is it is calculating the offset of the tiles that it's looking for in the data that we're writing in this file by indexing into this array and then backtracking to count up how many sprites make up the different entities that we're currently generating in the asset tool. And I realized that that's totally unnecessary because this isn't going to change ever. So it's probably better that it's definitely better that we would recalculate, or pre-calculate, I should say, the value that we need to index into these other array of bytes, because there's really no point in recalculating that every time. Save that and close it. So let's get to it. I've been thinking about this since Monday and itching to get in here and fix this. So the first thing is, this entity offset is kind of a misnomer. It's not really entity offset, it's more of entity sprite count. And the only reason that I want to change that is because we are going to generate something called entity offset, which is going to be the array that I was talking about before, where we actually have those offsets pre-calculated. So oh, I didn't make this work the same way as the other ones. That's fine. So entity sprite count, new line. Okay, so this can go away. This can go here. This is going to be the same thing as all of these other ones where we're defining a byte. And we're going to call this tile offset buffer, which doesn't exist yet because we haven't made it. And again, some of the stuff we're doing here probably isn't really the best, because we're writing all of this out as assembly instructions that we're going to generate in these files. Like this data, realistically, we could probably generate these labels and then or not realistically, we can definitely do the label and then use an include binary so that we can include the data we want. But I really want to be able to see this right now without having to go to a hex editor, so I'm just writing this out as text. Eventually we can fix that, and that's not a big deal to go back and change that, but that's why we're doing it that way right now. So let's see, so tile offset buffer, and then it'll eliminate the need for all of these crazy character formatting things we're doing. So we're gonna have to do the same thing here with the tile offset buffer, because the reason we're doing this in the first place is that the entities are all one indexed, because the 0th entity type is no entity. It's our sort of default non-initialized entity. So we have to offset all of that stuff in tile count buffer and tile offset buffer by one value. All right, so now at this point we just want something called like sprite sum. And all we're doing is we're going to keep adding to it the total sprite count. So we want to do that. We want to do that after we're done, after we've written to that buffer, essentially. So, right, because the first time through it's got to be 0, and then we add the number of tiles that we're writing for the sprite based on the entity based on the number of sprites, the number of hardware sprites it requires. So sprint fs formatting temp $hex. Oh, we need a maximum value there. Say total sprites. No. Sprite sum. Yep, sprite sum. And then once we've done that, we want to string cat it to tile offset buffer and max buffer size and tile offset buffer, and that's good, right? Yes. What? Oh, because it's not string ncat, it's string cat. And then after we're done with that, we want to, once we get the number of sprites in the next, for that current sprite, we want to add that to sprite sum. So sprite sum plus equal total sprites. And that is basically it, other than we need to make sure we add our comma. I guess we can do it right here. Because if we're doing the stripping of the comma, actually, yeah, it's kind of funny. I'm trying to do it from both sides, but meanwhile, I'm then stripping it off the end. I guess I don't need to do this because it should just get stripped off the end by the strip comma call. So that's okay. Let's see, we need to add the commas here then. Don't need to do this. That seems right. Okay, so let's just export the project. Ooh, what did I do? Tile offset buffer. Oh, well, that's not what I wanted to do. You can't string cat that into itself. All right. That was just a silly mistake. Chalk that up to being tired. Or, I don't know. Chalk it up to just a silly mistake. Alright. NES Asset Tool. And do I have that opened up here? No. Let's open that up. All right, so we have our sprite offset, which is saying, okay, the first entity has no offset, the second entity has a offset of 2, the third entity has an offset of 3, the fourth entity has an offset of 4. That looks correct, because every one of these should be the sum of the elements that are preceding this guy in the entity sprite count. So for this, that should be the sum of these two elements, which it is. This one should be the sum of the elements that preceded here, which it is. So you get 3. So that's looking good. That's what I wanted to do. So we got to change now this code a little bit. Let me copy over the modified files here. Is that called? Yeah, that's called draw entities. So let's close this one in the NES Asset Tool. And let's open up. Come on. Shooter. All right. So we'll copy. We really don't need to copy this one. Well, let's just copy them all just to make sure that we've got all the latest stuff. Replace the files. Cool. Let's go back to this. That got updated. We can build. Okay, good. So what do we need to change here? So the first thing we need to do is we need to get rid of this nonsense. We don't need to do this find index garbage anymore. We want to load a entity offset. That part is good, right? Because we want to get how far we need to index into the tiles array there. We also need the number of sprites. So we need to still go into get the value from entity sprite count. All right, so let's look back at this and see what we're doing. So we were decrementing table offset. And that's kind of the opposite of what I guess I wanted to do in the end, because I wanted to decrement the number of sprites we had populated, which I had put into temp. So some of this was a little bit backwards, I think, probably because I was kind of doing this very much on the fly, and also then getting a little bit confused about what was going so badly with it. All right, so we're loading the entity type and we're branching if it's 0 because it's not actually a sprite type. Or rather, okay, we're not. We're jumping if it is a sprite type, right? Because we've got to pull the value off the stack, because otherwise the stack will overflow with because of this that we're pushing on. And the reason we had to push that on is because that's the x's are index into this entity list. All right, so we're going to continue with the sprite. We want to offset. Let's see. So we're transferring a to x based on. Yeah. So all we need to do at this point is we need to, based on the entity type, we want to put that into x, which it should be already. Right. And then we're going to get the value from table. Okay, and then I'm going to put this into temp. Wait, no, that is the table offset that I'm getting here. So that's fine. What I also want to do is I want to load a from entity sprite count, right? Is that what I called it? Entity sprite count x, and store that into temp, because that's going to be how many sprites we actually have to write. Then the cool thing is that this all goes away. And then we just pull the a and transfer a to x, because we need our index back into the entities array. So that's good. So that's much simpler now. Now what we need to do here is we want to get the tile. So we want to load x with what? We want to load x with the entity offset value, which is the table offset. So we load that, and when we store, okay, and then we load a with the entity tiles based on the x value, and then we store it in sprite mem. We increment the y. The palette we're not dealing with right now. we have our X position, and we have to get that from the entities array. So we're going to get the X back that we had previously. And then we're going to store that into sprite mem. And then we're going to decrement the temp, and we're going to increment the offset. And then we're going to load a with temp, because we want to make sure that temp, we're using temp now to count down. And then we're going to branch if equal, and then that's that. And that all looks good now. So that's the modification we needed to do to switch to the pre-computed value, excuse me. So let's see what happens now. So if I hit start, okay, well, that is, okay, it's better. So if let's take a look at, it's definitely better, because before, as soon as I spawned any entity besides the player, the cycles were really bad. Here, it's actually not, I mean, it's not great. You know, let's be honest. We're getting 2,600 cycles, which is about 400 cycles more than we want. But before, we were well over 3,000 cycles. So that, in and of itself, actually contributed a lot to making this work a lot better. So that's exciting. So maybe there's hope for this yet. Okay, well, the only sort of caveat to all of this, of course, is that we're not doing anything with the X and Y offset. So what I need to do is I need to do that. I need to fix that. So we'll create X offset and Y offset. I'm hoping we'll be able to reuse these at some other point, but any tile, yeah, but we'll see. So the good thing is that it's very similar to this code where we load, what did I call it? Entity X offset and entity Y offset, I believe. Yep. So entity X offset X, store a X offset, load a entity Y offset, store a Y offset. All right, so I think what we'll do to start off with is we'll just add the Y offset and the X offset, and then see how that goes. So what we need to do is we don't want to get the actual X register back yet, right? Well, maybe we do. We do, okay, yeah, we do, because we want to get the Y position into A. This is not right. And then we want to add the value of the X offset. See, I wish there was a way. I wonder if there's a way. Oh, actually. Oh, wait a minute. No. This might be. This might work better than I was thinking, because let's see, the table offset is getting incremented, and that table offset is the offset into this, which is good, because I actually think we don't need to do this. Maybe we don't need Maybe we don't need those. I think we don't need those. And the reason I think we don't need those is because we should be able to just add them directly as long as we have the right X value that we need. So what we can do is transfer X to A and then push A, and then load A table offset. Load X table offset, and then clear carry, add carry, entity X offset X, and then we're good there. We already pushed this on, so we don't have to do anything for that. We just load X and we're good, and then palette we're not doing anything, and then we do the same pull and transfer for that, although we have to then, I wonder if we could, maybe we will use the entity offset, the X and Y offset variables, just so we can reduce the number of pushes and pulls that we're doing on the stack. That won't be terrible. So let's do that. X offset is 1. Y offset is 1. Table offset. So here, where we are already getting the entity offset, we can you do that? I should probably double check to make sure you can actually do that. I think you can. 6502 opcodes, add with carry. Yeah, you can. You can do an X offset there, or just an address. Okay. Well, so what I want to do is I just want to say X offset here. And where is it? Oh no, that's Y offset, because it takes Y first, and then we load A, clear carry, add with carry, X offset. Keep doing that, and then we have our new X value, which is cool. So let's see. Do I need to do this here? Maybe not. I can actually, well, I do need to do it. I need to do it every time through the loop, because I do need to get more than one. So transfer X to A, push A, do it after we get the Y position, and then we just basically do load A. Oh, but we don't want to mess with the Y position here. All right. Need to do it in the loop. Looks like we're gonna need to load X with that value. All right, so we'll just do push A, load A, table, no. Entity X offset, right? That's the spelling. Okay. Entity X offset X, store A, X offset, load A, entity Y offset, X, store A, Y offset, pull A. Handle X and Y offset by pushing X on stack, and then grabbing the X and Y offsets for later for use. Store A because it has the current Y position, Okay, grab the offsets, get our Y value back, and the offset. So that's pretty straightforward. And then get our entity index back. And that's simple because it's doing the clear carry-out. Okay, so let's see if we actually see the sprite properly now for the player, which is a multi-sprite. Oh, well, okay. I mean, it's actually formatted right, although it's not in the right spot. So something, so the X and Y is good. The Y, or sorry, the X movement is good. The Y movement is getting messed up. What did I do? I feel like I ask myself that a lot. Pull A, transfer A to X, load A, Y position. Oh, I needed to do that before messing with the index. So maybe that was it. Maybe that's all I... Whoa. That's cool. Okay. Okay, so we push our A, then we transfer X to A, and push that onto the stack. Oh, damn it. No, that's not what we want to do. Just want to do that in the opposite. Oh, well, that's gross. So the problem is we're pushing A onto the stack, and then we're pushing X onto the stack because we need X to have a value of the table offset in order to get the proper X and Y offsets. And then the problem is that we're only pulling this one time, and that's not even giving us our Y value back, it's giving us the value of X. So transfer A to X, that stinks, and then pull. We need to, basically what we need to do is we need to get, if we're pushing A and then X, right? And then we're pulling, we get X off the stack, and then we actually wanted this, not this, which means we need to do a little swap. I guess we just use a variable to do it. Do we have anything that we're not messing with right now? Are we using those? Bounding left. Oh, it is actually using those. Okay. Just call this temp2 because that's all it is. It's pretty meaningless. It's just a placeholder for the thing we need. All right, so we're getting. So this is actually get the X index back, store A in temp2, pull A. Transfer A to X, right? So, and then we're going to pull A again and store A in temp2, and then transfer X to A and push that back on. Well, that's no fun. And then load A temp2. Yikes. I feel like that's... I mean, that's probably going to work, but that seems pretty gross. All right, so yeah, we have our multi-sprite player entity now. But I imagine that cycles-wise, yeah, we're about 200 cycles slower than we were before. It's because of this. So let's see if we can be a little bit smarter about how we're doing this part, because there's really I feel like there's got to be a better way. You can do a store of X. So maybe instead of pushing it onto the stack, yeah, I think that's actually going to work better. Maybe what we'll do instead of stack operations is we'll use temp2 for our X value and forgo all this moving crap all over the place. All right, so let's see so instead of transferring X to A and pushing it, we're just going to store X into temp2. Right, transfer X to A, Y, right. So, okay, so we're just going to store it. So store X into temp2. So now we have A, which is our offset, into entity offset and entity sprite count. So that gives us those values that we need, and then we just load X temp2. Is that, am I making up assembler instructions? No? Okay. That's good. It's always nice when I'm trying to use valid assembly. So now, if that's the case, temp2 already has X in it, so we don't actually need to do any of this. Let me think about that. So if we load A with X, we've got the Y position in A, and then we're going to load X with the table offset value, which is good because then we're going to use that to get our X and Y offsets, and then we're going to we don't need to do anything with the stack over here anymore. So temp2 is actually no longer necessary. Oh, right, no, temp2 is still being used, but it's used for the being used for the X, right? So now we're gonna store, let's see, so we're loading A. So here we are, yeah, we can do the push A here. We're not doing anything with the X being pushed onto the stack, so now we can pull it off and add the Y offset. So that's good. That's all actually really straightforward. And then just to get the X back, we say load X with temp2, and then we load A with the X position, and we add the X offset and store that. And then we decrement and that is actually really good. So now we transfer X to A, we clear the carry, we add, and then we transfer A to X, and then we store X into temp2 because we need that for when we come back around to the top of the loop. because eventually we're going to clobber X with this load X, and then we're going to have to get it back, which we do down here by loading X with that value. That is maybe possibly more efficient. That seems way more efficient when it doesn't crash. Oh, you know, probably, let's see. Let's take a look at the stack. Am I blowing out the stack here? I sure am. All right, so let's see. Where am I doing some pushing and pulling? That would need to go away. Oh, so this pull is no longer necessary, right? Because we're not doing a push anymore. And then I don't think that would be it. That would be weird if that was... You go away, breakpoint. I don't need you right now. There we go. Oh, we're getting there. That's still much better than it had been. Oh, well, it was better than it was with the X offset added in, because now it's running at about 1400 cycles, whereas when I had put the X and Y offset in, it had gone to about 1600 cycles. I mean, it's between 14 and 1500. It's still not good, and it's not consistent. We're seeing... Excuse me, we're seeing the numbers here jump pretty substantially when we start adding entities to the list. So I want to see what else can we do to make this more efficient. So let's take a look. So we're still doing the pushing and the pulling of A. And I imagine that it's probably equivalent to be doing a push and a pull versus just a store and a load, at least on A, because for A, we don't have to do any of this juggling around like we do with X, right? Like with X, if you want to push it onto the stack, you've got to transfer it to A and then push A. So let's see, if we were to storing X to 0 page is 3 cycles versus... is that the bottom of the page? Versus transfer A to X and then push. So transfer A to X, yeah, so that's 2 machine cycles, and then push A is, I think I just missed it. Push A is 3 cycles, so that's 5 cycles versus just, and the pull is actually 4 cycles. Interesting. So load X, let me see that. That can be 2 cycles, and I don't have to do a transfer X to A or transfer A to X. Pull A, where does that go? So that's always 4 cycles. So that's definitely something to be avoided. So then should I just use another variable? Like that seems to be what I should be doing. Versus, let's see. I mean, and that makes sense, right? Because when you're dealing with a stack, you're not just storing in memory, you're also changing the stack pointer, the stack register, right? So push is 3 and pull is 4, so that's 7 cycles just for A versus load A, which on the 0 page, well, it's 6 cycles. It's 3 cycles for load A and store A. Store A is, yeah, so it's 6 cycles, so it is a little bit faster. So I guess that's not really the bulk of where we're getting hammered with performance here. I mean, part of it is, I guess, if like the y offset is 0, we're still doing the add with carry, even though we technically don't need to do it. I'm not sure how we would fix that under the circumstances, because like when we were doing the code, when we were generating the code in the asset tool, right, we could sort of intelligently say, oh, well, it's 0, so don't even bother generating the code to do the add. Here, I almost wonder if it's more expensive to, I imagine it's more expensive to check the value of the y offset and determine if we should skip this instruction, because then you're doing a comparison and a branch and some more shuffling of things. So that doesn't seem like a useful approach. Let's see. So we do need our x back for the position here. I mean, we could, well, I don't know if that's actually better. We could, instead of doing some of the shuffling around, we could change the order in which we're writing the bytes by incrementing the y. Right, so what we could do to reduce the, I don't know, is that going to reduce things? Eventually we have to get the x offset back to what it's supposed to be. Oh well, so wait a minute. It shouldn't have to do, well, I guess it does. So it's using the table offset here to get the x and y offset, then using that same table offset down here. Just kind of trying to weigh my options here. In the end, I'm not sure that we're going to get anything better than this, or at least not with my current level of knowledge of how all of this works. So the only other thing I was thinking about was we do have the ability to load A with a value of a pointer, and so what we could do is, instead of using x to instead of using x to index into the table, we had started looking at that approach last time. Right, I had created that variable tilemem, which I don't think is here anymore. I think I got rid of that. So we could do that. We could make all of these variables that we use to load the values we need based on a pointer. The question is that going to actually yield a better result than what we're doing here? Because we're doing, let's see, we're doing these two loads and stores, whereas, so we've got a load and a store that's going to be, you know, like 6 cycles, you know, 6 or 7 cycles. And then versus just doing this absolute load, which would be 4 cycles, but getting that offset set up, I mean, I guess that might work. I don't know. We're so close. Like, we've gotten it so much better than it was, right? It's actually definitely a substantial improvement from where it was before, but it's not good enough for it to actually work for the real game, unless we were to do something like artificially reduce the number of entities we can have, and we really don't have that many, I don't think. So if we were to change these, I'm going to move them. I'm going to create that tilemem again. So what I'm thinking we can do is we can say, okay, now that that's all pre-calculated, we say, all right, how do we do this again? So we would pre-calculate or preload these variables. We'd say load a tilemem. No. Load A with the lower, the upper? How do we do? It's the lower byte. Lower byte of entity tiles. Store that into tilemem, and then load A the upper byte of entity tiles, and then store that into tilemem +1. Right, this is that whole suspicious address thing. What was that? Did I have to do this? No. Can't remember what it was that I did to make that work. It was because it was looking at no. Oh, what was it that I was doing to make that work last time? I know there's, you can do low byte like this, and then high byte like that, right? Or is it, there's a dot low byte? $871. So load A with, oh, that's what it was. That was the problem with it. It was that it was, so that, yeah, if you remember from last time, I was telling it to load from the address of the low byte, or rather load from the address that the low byte resolves to, which is not what I wanted. I wanted the actual value of the low byte, so I can store that into tilemem and then tilemem plus 1. And then I want to do the same thing here for entity x offset. So store A into x offset, right? And then load a high byte entity x offset. And store A into x offset plus 1. And we just need to do the same thing for y offset. Okay, so those are our pointers now to the offsets. And then once we get the actual offset value that we need, instead of using the variable table offset, what we should be able to do is, well, actually, that's I guess okay, right? Let me think about that. Well, actually, I think we want to move this into here. Load A with that offset. Yeah. So, and then what we'll do, so basically we'll clear carry and then we'll add the low byte to the offset and store that, and then the high byte will get stored. But we want that same entity offset. Should I just push that onto the stack a bunch of times? I don't know. That doesn't seem necessary. We'll just do this, right? So we'll get it again, and then we'll clear the carry, and then we'll add carry for the low byte and store that there. So basically we're just setting up these pointers now to contain the actual specific address that we're looking for. And by doing that, then we actually don't care about X at all, right? Because now so we don't care about the table offset anymore. We do care about the sprite count. We don't care about temp2 because X is no longer going to get modified by us. And instead, what we're going to do, we don't need to load the X offset and Y offset values anymore like that, because we should be able to just grab it and add it to A. So get rid of this, right? Wait, what were we doing with that? Yeah, we don't need to do that. We don't need to touch A. So we're going to clear the carry, and then we're going to add carry, Y offset. And then we're going to increment Y offset. And then we're going to ignore this, and we're going to load A with tilemem, and then increment tilemem. Store that. And then the palette we're not doing anything with, and then we don't have to get this back because we never changed it. So we have our X position, and then we're going to clear, and we're going to do, well, this is right. And then we're going to increment that, restore it. We're going to decrement temp. We're going to ignore this because we don't need to do anything with that anymore. Load it. Okay, well, that seems better. Sort of. I mean, now we're dealing with... So we actually don't have to do the high byte every time, because that's not going to change. Well, I shouldn't say that. Technically, it shouldn't change. If we're careful, we could make sure that it doesn't change, but we don't really know for sure. Well, you know what? Let's leave it for now. Let's just see if this even works and is at all reasonable performance-wise and doesn't crash. Okay. I assume that there's just some dumb mistake I've made in the assembly code, so let's do this. Let's take our store here that's going to trigger the breakpoint and put it right there. And then reload the project and open the debugger and hit this and start. And that's not what we're looking for. It's here. Okay. So we're going to step over. This actually can go away. So we're not going to be touching that. So it's fine. Let's run. Enter, or start, I mean. Okay. So step over, load A. To get the entity type, it's 4. So it's not 0, so we're not going to jump to skip that. So we're transferring A to X, and we're going to load the sprite count. We're loading the sprite count, are we? The offset. Right, okay, so then we're loading the offset. Right, okay, so we're loading the offset value into A, and we're clearing the carry, and we have a tile value. Why do we have a tile value? Or is it just that it happens to be... Oh no, it just happens to be. Okay. So we're going to add 4 to 5D. So let's take a look at that, because I'm curious to make sure that we're actually referencing the right thing here. Hex editor. So the address is 855D, which is where our ROM lives. So 855D. So 855. This does look like tile data. Let's see. 59. Yep. So this would be FE. D. So that's actually reasonable. That's good. So, all right, the debugger is adding 5D to the 4, and then storing that in tilemem. Then it's loading the upper part of the address and storing that in the next byte after tilemem, and then it is going to do the same thing. It's going to get the offset again. It's going to add in. So it's doing all of this. Looks pretty good. This looks like what I expected it to do. Yeah. So we did all of that storing. What is this that it's doing here? So we got our high byte, low byte, high byte, low byte, high byte, low byte. And then it's loading the sprite count, which is, let's see, 64. This is, what is this? Load A. So A is currently 4. Load A, Y position. So we're in the portion of what are we storing in temp? Is that what that is? Storing the sprite count in temp. Yes. So we're going to step over, and that's 4 now. So now we're loading our Y position into A, clearing the carry. We're adding the Y offset value. Okay, so that's actually wrong. So why, or is it wrong? We're doing an add. Yeah, that's definitely wrong. That shouldn't be. Add carry. So add with carry can take an absolute address. Or an address with an index. Does that mean it's got to be? Are we running into the same problem where we still need the X? So it's loading the value of the address of Y, not the I guess I essentially want indirect. Grr. So it didn't work. And this is, I guess, what I ran into with tile memory from the tile mem thing from last time, and I didn't remember because so much had happened in that before. So 5A does have the value of 71, but the thing that I was hoping that it would do, foolishly, is take this address, this 8571, and load the value from that, and then we could increment that byte So it's essentially, we're running into the same problem now. So sprite mem is doing it right because it's using Y to index indirectly off the pointer. For some reason I just had it in my head that we could, where is Sublime Text? For some reason I had in my head that we could do that without using Y. But actually, could we use Y? Because Y is steadily incrementing from 0. If we could lockstep this somehow so that we could use Y, then we could make this just all right, because basically what we would need to do is we would need to say, okay, so right now we're incrementing the value of the low byte of the entity tiles address on the ROM by the offset. The problem is, though, that the only way to get at that now that we have the address in memory is to use X or Y to tell the CPU that you want to use the address in entity tiles, or sorry, tilemem, not the value at the address of tilemem. So if we could set up the low byte of tilemem to compensate for y's current value, we could then use y to do that. So how would we do that? So we would just subtract the value of y from, yeah, so what we would, yeah, that might work. That's crazy enough to work, maybe. Possibly, probably not. Subcarry. I guess I have to set the carry first before we do the subtraction. Can you do that with just the... Can you just subtract the y value? No. That would have made it so much easier. Because now I have to do a transfer. You can add a memory address, but you can't poop. Alright, so what do I want to do? I want to do store y into temp2, which we're no longer using for the x offset, and then set the carry, set the carry and subtract c temp2. This is maybe crazy enough that it might work. We don't have to store that again, we just need to subtract it. And then we use y as our index, but we've compensated for the value of y such that it should give us what we want even as we iterate through the higher entities in memory. This is going to be interesting. So let's... That built, right? Okay. Debugger. You have a breakpoint that I'd like you to release, please. So we're past the start, the title screen. All right, so let's see if we got this right. We're checking the entity type, it's the player. So now we're going to transfer it to X because we want that index for the sprite count. And then we're going to add that value to... So we're going to add that value to, what do we start with? We start with entity, tilemem, and we stored y off so that we can offset by it. So we set the clear, we subtract, which had no change on the value, and then we store it, and then we just keep doing that essentially. And then when we go to look up the values, does this work? So it's only using a 1 byte. It's only using the base byte for the lookup. So why is that? Load A. Well, no, wait. is that the, where are we in this part of the code? So load A, position X, and then we're going to do the clear carry immediately. This isn't that. This is... This was subtracting the Y position. And storing it in the offset, and then load A 85 with address. Okay. I just lost track of where exactly in this code we are right now here, so bear with me a second. Load the value. Oh, okay, right. So it's still okay, so that was still dealing with the, this was still dealing with the high byte, low byte stuff. Load A, store it, load A. So this looks to be right. So we're getting the sprite count here, and then we're storing it into temp. Okay, I know where we are now. So now we're loading the Y offset, loading the Y, right? Store A, yes. So we're loading the Y offset. We're clearing the carry, doing an add carry with the value. Yeah, so at yes, that looks right. That actually looks right. So we step over, we store it into our sprite mem, we increment Y. Oh crap, right, we increment Y. So it's not enough to just have damn it. Okay, so we actually got to change the order we're doing this, because we have to compensate for the fact that Y gets incremented with every step of populating the memory. Okay, so let me think about, okay, yeah, so I'm just gonna take this whole thing and we're gonna do this here, and then we have to increment temp2, and then it's the tiles, so that's good, and then we increment temp2 again, and for then there's going to be another one to compensate for the palette, and then we do the X offset. Okay, so that's actually, that wasn't too bad. And in the end, sadly, all of this is, you know, just us experimenting with this alternative approach to handling not generating the code in the asset tool. We may not be able to get this to be as efficient as that. Or, I mean, I don't, let me backtrack. I don't think we'll ever get it to be as efficient as that, but I don't know if we'll ever get it to be close enough that we can use it. That's the problem, right? That's what we're striving for. We're working to see if we can get it to be efficient enough that we can use it, so that we're not just generating a bunch of code. But we may not be able to do it. All right, so what I'm interested in now is, this is the title screen transition. All right, so we are not interested in what's going on essentially until we see load A, clear carry, add C, inc. Load A, clear carry, add C, inc. So over here, so I'm going to hit a breakpoint here, because at that point we are now processing the actual sprite stuff, right? So we are loading the Y position, we're adding the offset, we're incrementing the Y offset value, and storing that into sprite mem. And we're incrementing Y again. And then we're loading tile mem. So now that should be 5D, not 5E. So we're actually off by 1, it looks like. Which, I mean, that's actually not terrible if that's all it is. Oh, did I? Oh, I think I know what I did wrong. I think I... Whoa. Well, that's fun. I think I may have... I should be decrementing, right? Because I'm subtracting temp2. So let's see, if it were 0 there, then the next portion that we're dealing with is the entity tiles. So Y would have been incremented, which means we need to decrement it. Yeah, so I need to go in the opposite direction. And then we're good there, I think. Is this still going to be a problem? Are we going to have to mess with this every... Yeah, if it's a multi-sprite entity... Man, this is kind of messy. Because if it's a multi-sprite entity, then the problem is that... it is... The gap between the two things is getting wider and wider for the offset here. So that's not going to work. I mean, I'm sure we could make it work, but now we're getting to the point where we're adding so much code to make this happen that it's kind of like, I know it's not going to be as efficient as it should be. So if we go back to not doing this, okay, so that's where we started messing with this again. So this should now be functional, if although not as efficient as we want it to be. Yeah, I'm not sure that there's much we're going to be able to do to make this work better. I guess we're just going to have to handle the code that we're generating and making sure that it's not going to have a problem with the range problem. Because this is just not going to cut it if we want to be able to have a lot of stuff on screen. Right? Like that's why it's glitching out like that, because we just have too much. So, alright, well, here's what we can do. Like I said on the previous stream where we started down this road, I said, well, it's not a big deal. We can always revert the changes because we're using source control. The other thing we have the ability to do, because we're using source control, is we can save these changes and not worry about if we decide we want to come back to this in some capacity. So what I can do is I can do a stash. So I can save these changes off in a stash where it, we can come back to it knowing that it is busted, but has some sort of potential here. So attempting data-driven sprite rendering. So that took the change and it put it into this stash, and we're going to do the same thing here, which is where we changed all of our code to handle the functionality where we are no longer generating the code. So we'll do the same thing here. Probably want to use the same stash. Attempting data-driven sprite rendering. Well, changed over to use data-driven sprite rendering. And when we come back here, if I didn't screw this up, so we're back to the code that we had before. And Visual Studio. If we go back to this, this should now be doing what it was doing before, where it was generating all that code. So let's copy the generated content here back to the shooter folder. So this is now assembly code like it was before. We don't need this to be there anymore. So that assembled. And FCUX is not running. If we open up our Lua script for timing the cycle count, while the graphics the colors are wrong, you can see I can spawn all of my entities, and we're not over 2,000 cycles. So while this can probably be made more efficient, it's already inherently far more efficient than the previous approach, I guess by quite a bit. I mean, again, so part of that is the fact that the previous approach, instead of just running through code, was trying to determine what needed to happen, right? So whereas this is saying, okay, for the blaster, it's 2 sprites, so you do this, and then you do this, and it's very straightforward, and it only increments the offsets if there is an offset value to increment by. So like in this case, it adds the 8 to the X increment so that the blaster shows up properly. If we go back to that in FCUX, just for a second. Right, the blaster is it's that two sprite guy there. Actually, we can look at it in the asset tool. Where is that? So the blaster is 2 sprites, right? Because it's in a 16 by 8. It's just writing code that does that, and that's going to be more efficient than what we were doing. It was just a question of how inefficient was it, and could we make it work? Because obviously this is a lot more code, whereas the other approach was not nearly as much code, but obviously required more processing power to make it work. So we can always come back to that. I'm not surprised that that's the way it went. I kind of suspected that was what was going to happen, but it was bothering me that we hadn't tried it. So spent a lot of time on that. Let's fix something else that's in the asset tool, and then I think I'll call it a night, because the stream on Monday was 3 hours. I don't intend on doing a 3-hour stream tonight. I'd like to make this pretty reasonably timed stream. So the only thing that I wanted to really take care of is, right now we have our palette view that's being rendered, and it's just the 4 colors in the palette. The problem is, right now, when we have the palette being loaded by the tool, like, so we have this PNG that I created, and when it generates the sprite, it's grabbing the colors and it's matching them up to indexes for the colors in the NES palette, and it's writing it out, and it's writing out an indexed value that indexes into this. But as you can see, the first value in the palette here isn't this black color, and it needs to be, because what's going to happen now is that when we look at the sprite in the game, we're not going to see the blaster with the transparent background. What we're going to see is this color, and this dark gray is going to be the transparent background, which is wrong. I think just for sort of a quick and dirty fix for this right now, what I want to try is I want to check to see if you've right-clicked on a color in the palette. And if you have, it will automatically swap that with the 0 color. So it'll just swap the color value. That's not going to be sufficient, because what will happen is, like, if this black color gets swapped with this dark gray color, then we're going to see the reversing in here. It's not going to render it properly. So we'll, as a side note, we need to somehow re-index this sprite. But let's start with the mouse. So we say tiger mouse, and what is it? Is it main window, and then we have our mouse X and mouse Y and mouse buttons. So in mouse X, mouse Y, mouse buttons. And that's all it takes. Yep. And then we want to check, okay, are we within the X and Y value of the palette? So if my is greater than y, and my is less than y plus, what is it? So it's 32. It's going to be a fixed width. I think I said they're 32. Yeah, so they're 32 by 32 squares, so they're 432 squares, so it's 128. So if it's in that range, and then mx is greater than x, and mx is less than x plus 32. Oh, wait a minute, I'm reverse that. So we're in the bounds of the palette. Then check the mouse button. So if mouse button N2, I assume, but I shouldn't, I assume that the second bit is the button 2. It is. Okay. So that's cool. So what we want to do is we say mouse button 2, and then we got to see where the heck we are in this thing, and we just do that by dividing the x, the mouse x minus the x by 32. That'll give us our palette value. Let's just start by making sure that I'm not delirious here, and we actually will get a palette value that makes sense here when we right click. So if I click on the blaster and I right click here, hello. Okay. Why don't I see my print statement? Where's my console? That is an old one. I don't understand. Am I just losing my mind here? Oh, because it's not 2, it's 4. All right, so the middle button worked, but not the right button. Okay. I didn't realize that that's what it was doing. Okay, good. So that's good. Those are the indexes into the palette. So what I want to do to start off with is I just want to change node palette data palette int index equals mxx divided by 32. So we saved, let's see, so we saved the color of the one that we clicked on, and then we're going to make that one equal to indexed 0, and then 0 will be equal to temp, so that will swap. That should swap the colors now. Okay, well that's the reason it's not taking permanent change is because we're not changing the palette that's actually being passed in here. So what we should really do is copy that back and modify the palette we're passing back, because we do want it to change to the new palette size. And these are actually chars and not integers. So that should make that change permanent, or permanent for the session that we're working in. And also it keeps flipping it back and forth only because we're not checking to see if it was previously pressed and then released. So I believe there is a button. Yeah, there is. Okay. So I was pretty sure there was a button variable here. So if node button equals 0, or if not node button, then node button equals 1. So if, actually, sorry, I'm starting to fade here, and not node button. Just say node button equals 1, and then else if mb equals and 4 equals 0. So if the right mouse button hasn't been clicked, but node button is set, then we're going to actually execute on this, right? So we only want to do this when the right mouse button has been clicked and released. Oh, we have to then say node button equal. Well, let me do this. Let me hit a breakpoint here. We got to zero out node button so that it doesn't continue to try to make these changes. There we go. So it's swapping. All right, good. So that's cool. That's what we want. Now, the only other problem is that even though we're swapping the value in the palette, we're not actually doing anything to notify the caller that the palette has changed, which we need to do. And the reason, so let me think about this. I think we probably want to just make it as a Boolean return. Basically, the idea being that, you know, has the palette changed is what it's returning. So, you know, we'll say return true. Otherwise, you return false. And basically, you want to look at this and say, okay, if the palette has changed, then, well, then we need to go update the image that we're currently viewing, because it needs to change too. So is that what I called it? Palette view? I guess it is. It's the other problem with only doing this 2 days a week, is that I sometimes forget what we worked on or what I called things. It's actually harder, I think, to code this only 2 days a week than it would be to do it every day. Because like with the stuff we were working on last time where it was totally broken and not working well, I really wanted to fix that, but I didn't want to change that off stream just because it is actually relevant to the NES game. And that, I think that's probably more important to show on stream than some of this other stuff, like with the tool, because like these are the kinds of things that you're going to have to do because the NES is so slow and limited in its capabilities. So, all right, the palette view change, then we get true here. Again, let's just validate the insanity. Okay, good. So we're not getting any crazy multiple triggers or anything like that. So test is saying, okay, we got that changed. So now we have to go through and update the image. We have to go back and re-index the image essentially. Well, so now that's interesting because we don't even know what changed. We just know that. Well, let's start with we want to redraw essentially the image. Right? Because right now we are not, yeah. So can I just make a call? Yeah, I guess we can do that. So right now what's happening is the image is already preset in the this image pointer here, but the problem is that we have changed the palette. I want to do this before we add the image to the UI. We've changed it, so we got to update the image. So sprite to image, current sprite. Oh, well, actually, no, I don't want to. Do I want to make a brand new image pointer? I guess that's okay. So if image tiger free image, that's kind of messy. I mean, we technically don't have to do that, but it's not the end of the world. We'll fix that in a second. I just want to validate that this is actually going to change. Why didn't it change? Oh. Image changed equals true. There we go. So now when we change the palette, it's redrawing. And, you know, we could actually mess around with this enough times where we get the color combination that we want. But obviously that's not ideal. And then we have to be able to save that change. So I don't want to... Here's what I can do. I'm going to pull this code out. And make this a function called drawSprite. It takes an image and it takes the sprite. So void drawSprite, and it takes a tiger image and the sprite. And then it actually draws that onto the image, and then we can reuse that instead of having to build a whole new image, because the image size isn't changing, so there's really no reason to get a whole brand new image. drawSprite, image, current sprite, image changed is still true, so that should take care of it without allocating a new sprite. Sorry, a new image unnecessarily. And it does. Excellent. Cool. So now what I want to do, instead of just swapping the colors, is I actually want to swap the indexes, or the indices if you prefer. Swap those in the sprite itself. So how would I do that? Because I don't currently know what actually changed. I just know that it did change. I guess what I can do is make this so that it returns back or populates the indexes that were involved in the switch. Right? I can say swapped indices. So swapped indices will just be a two-int array, and GUI will take a integer pointer, swap indices, and it will actually, well, that was dumb. It actually only needs the one int, because it's always swapping index 0 with some other index. So it doesn't need both. It just needs the one. Swapped index. Okay, so call it swapped index. Pointer swapped index. And in the case that we're going to actually do something, we say if swapped index is not a null, swapped index is equal to index. The braces. Doesn't take 4. Oh. I don't care about the swapped index here because we're not going to actually do anything with it for the PNG. So that's fine. We can even make that a default parameter so that I don't have to include it here or anywhere that I don't care about if the index swapped. Super. Okay, so that's good. So that's our swapped index. So before we go to draw the sprite, what we need to do is we need to iterate over the sprite and swap the values of, so we want to swap 0 with the swapped index and the swapped index with 0. So int total bytes is equal to current sprite width times current sprite height. Probably pre-compute that instead of having to redo this every time we need it, but not a big deal right now anyway. And then for int I is 0, total bytes plus I and current sprite if equals swapped index current sprite image I equals 0, else if not current sprite image I current sprite dot image I equals swapped index, right? Because we're just doing an old switcheroo on those two colors so that the image looks the same, but the indexes are now different. Yeah. Cool. That works for that one. That actually has it in the right order. That does not. We would do it like that. Oh, well, actually, that's an interesting case where it's using... I don't think this is using 4 colors. I think this is using... I may have to add something to show what the colors are there that it's putting in. And this, we switch like... Okay, that's cool. That's working. So we need to add a Save Sprite button because we need to be able to save the sprite after we make those changes so that they're permanent. So let's see, where's export project? So if GUI button still don't like that we have to do this whole nonsense of supplying an ID, but I haven't really gotten around to fixing that yet. So sprite selected is the balloon we want to check. So if sprite selected, we'll add our button, and we'll do it right above the export project button here. We'll say -80. Save sprite, GUI anchor right or GUI anchor bottom. And our usual sanity check here, just to make sure that this is going to look right, and click that, and there's save sprite, and we click it, and it says hello. Okay, that's good. So now we have our create sprite call. Load sprite, create sprite. Is there just a save sprite? No. So let's make that save sprite. And this is going to be really easy because we have set ourselves up in a way that this should be straightforward. Right? Technically, I guess this can be const. So we need to create the file that we want to write this to, and I believe that that is part of, yep, the file name is part of the sprite, although I don't remember if it's the full file name. We'll find out in a minute. So I want to need a file handle. So I want to get the file handle, and we have our sprite file name, and we're just going to copy all this garbage. If file is greater than or equal to 0, meaning we opened it properly, let's close the file here so we don't leak handles. So we want to do a couple of things. So the sprite structure has, if you remember from when we talked about this, it's got these two pointers. It's got image and it's got this bounding boxes array. We need to save these off, temp image, because they don't actually mean anything once we've written this to a file. So image and temp bb equals sprite bounding boxes, and that should be a vector too, not a right. And then I want to null these out because I don't want to have a mistake where I accidentally try and use these values. Oh, it doesn't like that. I'm not really. All right. Again, another case where it's protecting me from something I know that I'm doing that's fine because it's const, and it's just going to create more problems than it solves by making me preserve the constantness. So don't care about that. What I want to do, though, is I want to write to my file first the sprite, which is the size of a sprite. And then I want to write my indexed image, right, which is file. That's going to be temp image. So like we want the data, right, but we can't reference it by the pointer here because that's definitely not going to work. And then the size of that is size of character times sprite width times sprite height. And then we want to write our bounding boxes, which are just an X. What are they? They're just an X and Y, right? Yep. And then I can't remember, is that a fixed size? Okay, so it's size of vector 2 times bounding box. Oops. That's not the replacement I wanted. Bounding box size times new times sprite number of bounding boxes. So that is that. That saves it out. We got to replace those pointers with the temporary values so that they actually continue to work properly. And then we close it. Okay, that is good. And now we actually want to call that. So let's do it. Save sprite. Current sprite. And that should be it. We'll know if it worked or not if we come back to it after saving and it actually has the change we want, or if it got messed up. Interesting. So the palette change did not get saved. Let's see what it's doing when we call save sprite. So it's going into there. Let's take a look at the temp image because I wonder if... Oh, you know what? That is a good point. So the reason this isn't working is because although I'm rebuilding the indexed image in the image itself, I don't believe that I am actually changing the sprites. Well, no. yeah, that wouldn't work. So scratch that. So it's changing that. It is re-indexed properly. What is the palette? Oh, wait a minute. The palette is getting changed. Is it calling? No, that should get saved too. Let's take a look at this here. I thought I wasn't saving the change of the palette itself in the palette. That's broken. Image was null pointer. Yes, no, that's not good, but stop. We'll fix that in a second. So if I change that, let's see, the palette for the current sprite should have been rearranged. So current sprite dot palette. So we've talked about this before. The 0D value is no good, but we will deal with that another time. If I swap it again, okay, it is in fact swapping it. So it's getting changed. This. Wonder if is something being cached somewhere? No, it's just not. Well, poop. That's not good. Let's take a look at that file that we just wrote. Hopefully we just wrote it. Maybe that's the problem, is that it's not actually updating the sprite file. Possibly. Oh, crap. Okay. It's not that. It's... I hope I have that saved somewhere. I do. So the reason that PNG failed to load is because it was corrupted by the sprite that we wrote out. Because in the call to save the sprite, we were using the file name. Unfortunately, it looks like the file name that it's using is actually the PNG file name. So create sprite. Yeah, so it's using the file name of the image. We really want to replace that. Replace file extension. New sprite file name with .sprite. I think you actually replace file extension. Yeah, okay. Yeah, I wanted to reference, I guess we could probably reference the original image if we really wanted to, but I think it's, well, yeah, I think that's probably actually more valuable to keep in the file, and then instead we can just pass file name. So that's going to break. What is, do we save the current file somewhere? I don't remember after we've selected it if we have that current file list I name. Let's save off the current file, current selected file. Or do we have the selected index? We do have a selected index, so we don't need, well, assuming we're actually populating that properly, which we are. If it's an image, really we should just populate that no matter what's selected, because unless it's really not an image. But for the sprites and images, that's fine. We say current file list I file. Huh? Is it current? What is it? Current item list? Current file list. Why is it not auto-completing? Current selected. Image index name. Okay. I want to go with full path. Okay. So hopefully this will not corrupt the PNG this time, but will instead save our sprite. Save. Go to here. Back. Yeah. That's what I wanted to see. So that's swapped. Save the sprite. Awesome. So now let's export that whole thing out. Close this up. Get all our stuff again. So we do need to transfer all that stuff back over to here, because now it's updated the images with the appropriate 0 index color. And then we can build it. We have FCEUX running, so let's relaunch that. Cool. So the colors are wrong, but now everything has the proper transparency, which is what we were going for. Sweet. Okay. We're getting there, making progress. Still have a lot to do, but I think this is a good stopping point. We've got things working, and we fully, perhaps at the risk of becoming frustrating for some people watching, we investigated that approach, you know, to the fullest extent that I think we probably wanted to prove that it's definitely not as efficient as generating the assembly code. The next step is we need to handle these sprite colors better, and I also am going to start building the tile mapping for the level, right? Because we need to actually have something for this ship to fly through so that it's a game and not just a ship flying and shooting random enemies that I spawn by pressing the B button. That, of course, will require some considerations of what we want the game to actually be in terms of how the game mechanic works, like what you're actually trying to do in this game. Besides shoot things, that would be nice. We got to figure that out. I got to figure that out. And then we start the new hell of loading the backgrounds and scrolling the backgrounds and loading that. And do we want to be supporting scrolling in 2 directions or just one? Meaning, like right now, when you move the ship, it does not scroll from left to right. It is just scrolling that background over and over again. So beyond just populating the name table with the appropriate tiles for the background, do we want to support something like being able to move back and forth to give the game a bigger playing field and make it feel like a much more sort of epic shooter? Or are we good with just having the one screen width? So I got to think about those things and figure that out. But not tonight. I'm going to wrap it up. Anybody watching the stream have any questions in the chat? All right, well, nobody's jumping up and down to ask questions, but as always, if you want to reach out to me, I'm on Twitter at Clairvis. These videos get posted to YouTube, and I'm on the Nintendo Age Discord. Great bunch of people there, great community. If you're interested in NES programming, definitely should check it out. The forums are awesome too. Anyway, thanks for watching, and I'll see you on Monday of next week. And if you celebrate, happy Easter, and have a great weekend. Take care.